My name is Stephanie Saylor, and this is a visual phasing workshop. We will be reviewing how to mark recombination points in example C of the tried examples in this session. You should have taken some time to teach your neighbor or work on it before watching this video. If you have not, please find the tried examples in the description box below and pause the video while you teach and are taught, if you are learning with a friend, example C, so you can get the most out of this review session. Let's start by addressing the green over blue, followed by the yellow over blue at the very beginning of Willow and Mabel's comparison. There is not a relevant change below it. If we look directly below, that's not a change, that's not a change, that's all half identical, this is all no match. And so we know that this is not a relevant stretch of fully identical segment. So it is simply some green mixed in with the half identical segment. And I'm just going to say that this doesn't look relevant and move on. We would know it was of useful size if down here, if there was blue under this yellow box. That means it would have exceeded our threshold for being useful. If you're looking at a possible bar of green and wonder what would happen if I said it was not relevant and it ended up being relevant, we would see that we would have 3 changes to address, or 1 lone change on. So when looking at changes like this, there would be a 3rd change down here without another one to pair it with. Or we'd have a single change somewhere and we wouldn't know what to do with it. Sometimes that does happen though, and when that happens, instead of marking it with a red bar and mark it with a gold bar, but usually those problems are solved by just recognizing where these false segments are. So our first real change happens here in the comparison between Willow and Kate. We move from a no match gray on the bottom to a half match, yellow on the top, blue on the bottom. Below we see our second change, where it's a half match, yellow on the top, blue on the bottom, moving to a no match, that gray brown on the bottom. And we can insert our line of recombination. Our next change happens in the Willow and Mabel comparison, where we see a half match, yellow on the top, blue on the bottom on the right side of that line of recombination, followed by this gray-brown bar at the bottom, meaning no match. And when we look below, we see again a half match on the right side of the line of recombination, yellow on the top, blue on the bottom, but this time it's followed by a full match. Green on the top, blue on the bottom, meaning Willow and Kate share DNA on both copies of chromosome 5 with each other. So we can insert our second line of recombination. Moving on, we see another change here, where Willow and Mabel went from sharing no DNA in this section of chromosome 5 to sharing DNA on one of their chromosomes, as we see by this half identical match, yellow on the top, blue on the bottom. And when we look below, we see our other change, where we move from that fully identical segment, where Willow and Kate inherited the exact same DNA from both parents in this segment of DNA, followed by only inheriting the same DNA on one of their chromosomes, so only the same DNA through one of their parents on this segment that's half identical, which is marked by yellow on the top, blue on the bottom. There's no third change where we see this gray and brown no match, so we can go ahead and insert our line of recombination. And our next change, we move from a half identical segment where we've got yellow on the top, blue on the bottom, to a point where Willow and Mabel do not match at all for this segment of DNA on either chromosome. Moving to the bottom, comparison between Mabel and Kate, we see a no match, followed by a half match, yellow on the top, blue on the bottom. And since there's no third change, we can go ahead and mark with confidence our line of recombination and move on. Here, Willow and Mabel move from not sharing any DNA with each other to sharing DNA on one chromosome with that yellow on the top, blue on the bottom. And when we move down, we see that they move from sharing DNA on one chromosome, yellow on the top, blue on the bottom, to not sharing any DNA with each other. And if we look below, we see no change down here, yellow on the top, blue on the bottom, half identical segment all through the area. So we mark our change and move on. In this change here, we see that Willow and Kate move from a no match, where they have that gray-brown bottom, to a half identical match, yellow on the top, blue on the bottom. So they share DNA on only one of their two chromosome 5s. And our second change is below, where Mabel and Kate move from sharing DNA on only one of their chromosome 5s, or on chromosome 5 through only one of their parents, to sharing DNA on both chromosome 5s because they inherited the same DNA from both their parents. To see no change up here in the Willow and Mabel comparison, so we can go ahead and put our line of recombination in and move forward. Willow and Mabel here have a change, moving from half identical, yellow on the top, blue on the bottom, to a fully identical match, green on the top, blue on the bottom. And when we look below here, there's no change in the Willow and Kate comparison, but there is down at the bottom in the Mabel and Kate comparison, where we move from green on the top, blue on the bottom, to yellow on the top, blue on the bottom, half identical match. And here we have a full identical match. So we can go ahead and put that line of recombination in. When we look at the middle comparison between Willow and Kate, we see they move from sharing a segment of DNA on one of their chromosome 5s to sharing this segment of DNA on both chromosome 5s. So they inherited DNA from both their parents that was the same. Looking below, we see another change where they move from sharing DNA on one of their chromosome 5s in this segment to sharing DNA on both their chromosome 5s in this segment because they inherited the same DNA from both their parents. Here in the Willow and Kate comparison, we see a fully identical segment where DNA was inherited from both parents to a half identical segment where DNA was inherited from only one parent that was the same. And that same thing below, that green on the top, blue on the bottom, fully identical segment from where they inherited DNA on both copies of chromosome 5 that was the same between Mabel and Kate, and where Mabel and Kate only inherited one of the same copies of chromosome 5, or only inherited DNA on chromosome 5 that was the same from one parent. The last change on this chromosome we see starts up here in Willow and Mabel, where they move from sharing DNA on both copies of chromosome 5, which we see from that green on the top, blue on the bottom, to a half identical segment, yellow on the top, blue on the bottom. So our change happens right here. And when we move down to the Willow and Kate comparison, we see a half identical segment, yellow on the top, blue on the bottom, transitioning to a fully identical segment, green on the top, blue on the bottom. And so now we have marked all recombination points in example C. I gave example C names so it would be easier for you to follow, as changes the order in which the names appear for our maps and our comparisons. And so that will affect us a little bit more later. So I wanted you to have an actual name instead of a letter to help you pull those steps together and to see the difference it makes when you have to switch your brain between a different order. As part of the reason why you want your template to be in the same order so you don't have to worry. Go ahead and pause the video and take the time to mark combination lines in your personal visual phasing project. Do this on at least one chromosome, and I recommend you start on the X chromosome or one of the last 5 chromosomes